Let us see few terms which are related with a greenhouse. Okay, what do you mean by greenhouse? We have seen in the first topic. The term greenhouse, it refers to a structure which is covered with a transparent or translucent material for the purpose of admitting natural light or plant growth. That is greenhouse. Then we have studied uh, this definition of greenhouse. Then what do you mean by greenhouse range? When two or more greenhouses in one location are constructed, then these are referred to as a greenhouse range. Okay, two or more greenhouses in one location are referred to as a greenhouse range. Then service building or head house, a building which is associated with the greenhouses. It is used for storage or for operations in support of growing of plants. Is term or is referred as a service building or head house. Okay, the building in which different greenhouse operations are carried out. It may be sorting of the flowers or sorting of the fruits. Okay, or pre-cleaning of the fruits after harvest. Okay, so such a building, it is nothing but service building or head house. Then let us see design criteria of construction. Let us see first criteria for locating the greenhouse. Here, a piece of land which is larger than the grower's immediate need, it should be selected or it should be acquired. Means here, when locating a greenhouse, a site selection, it should be done in such a way that grower can uh, immediately enter into that greenhouse structure. Then next, the ultimate size of the greenhouse range, it should be estimated. Then that is dimensions of the greenhouse structures or overall greenhouse project. Okay, it should be estimated. Then area should be added to this estimated figures to accommodate service buildings, storage building, then access drives and a parking lot. Here, the floor area of service buildings required for small firms is about 13% of the greenhouse floor area, and it decreases with increase in the size of the firm. Okay, the floor area of service buildings required for the small firms is about 13% of the greenhouse floor area. Okay, and it decreases with increase in the size of the greenhouse form. Then next criteria, on an average, service buildings occupy 10% of the growing area. Then the service building is centrally located in a nearly square design of the firm, which minimizes distance of movement of plants and materials. Here, the doors between the service buildings and greenhouses or greenhouse, it should be wide enough to facilitate full use of corridor width. Here, dimensions of the doors are given here. Doors having the 3.1 meter width, 2.7 meter height are more common in use. It is good to have greenhouse gutter at least 3.7 meter above the floor of the greenhouse to accommodate the automation and thermal blanket and still leave the room for future innovations. Okay, so in this way, here different criterias are given for construction of a greenhouse structure. First criteria is regarding the selection of a site. Okay, it should be closer to the grower's residence. Okay, then about the size and dimensions of that greenhouse structure, about the uh, one of the criteria about the floor area of the service buildings. Okay, then Here that service building it should be located. Then what should be the doors between the service buildings and greenhouse structures? What should be the dimensions of such a doors? Okay, all such a things are incorporated in the design criteria for construction of a greenhouse structure. And next to that is the greenhouse ventilation. Now, what do you mean by ventilation or the term ventilation? A ventilation is the process of allowing the fresh air to enter into the enclosed area by driving out the air with undesirable properties. And is ventilation. The process of allowing the fresh air to enter into the enclosed area or into the greenhouse structure by driving out the air with undesirable properties, that is ventilation. In the greenhouse context, ventilation is essential for reducing the temperature, replenishing the carbon dioxide, and controlling the relative humidity. So, to have control of temperature, CO2 level, and relative humidity control, here ventilation is essential. Ventilation requirements for greenhouses varies greatly depending upon the crops grown and the season of crop production. Here, the ventilation system can be either a passive system, that is natural ventilation system, or an active system, that is forced ventilation system using the fans. Here, usually the greenhouses that are used seasonally, they use natural ventilation systems only. Let us see about the first ventilation system, that is natural ventilation, or we can say passive ventilation system. Here in the tropics, the sides of the greenhouse structures are often left or these are kept open for natural ventilation. Tropical greenhouse is primarily a rain shelter, a cover of polyethylene over the crop that mitigates the problems of foliage diseases. Okay. Here, in case of the natural ventilation, see this diagram shows a section or a cross section of a greenhouse structure, inside of which such a benches are there, on which such a trays or tubs are kept, in which such a plants or the crops are being cultivated here. Okay. Now on the both the sides, okay, of this greenhouse structure, just side ventilators are provided by means of such a ventilators in the side walls. Okay. Also, you can see this is the roof of that greenhouse structure, and this is the reach of that greenhouse structure. Okay. Here, a foldable roof ventilators are provided here on this side also and on this side also. Okay. Let us say ventilators are located on both the roof slopes adjacent to the reach and also on the both side walls of the greenhouses. Ventilators on the roof and side wall accounts each about 10% of the total roof area. Okay, ventilators should be provided in such a way that here area occupied by such ventilators on the roof, okay, it should be 10% of total roof area, okay, to achieve effective natural ventilation. Here how this natural ventilation flow process it takes place. Okay, during the day, due to the solar radiations entering inside this greenhouse structure, what happens due to the greenhouse effect? Here temperature inside that greenhouse structure it increases. Okay, so due to the more or due to the high temperature inside that greenhouse structure, what happens at air inside a greenhouse structure? Uh, it becomes warm or it becomes hot, due to which its density it decreases, and due to the decrease in the density of that air, it becomes light in weight and it moves or it gets lifted up inside a greenhouse structure, and it gets removed through such a ventilators which are provided in the roof into the ambient air. At the same time, from the side ventilators, here ambient or the cool air, okay, it enters from the sides into that greenhouse structure. In the place of such a warm air, it is taken by it cool or that ambient air. In this way, flow of air from ambient air inside a greenhouse structure and from the greenhouse structure into the ambient air, it takes place. That is a chimney effect. It is generated due to such a flow path of the air. Okay, due to the temperature differences. That is chimney effect is generated. Okay, let us continue. During the winter cooling phase, the south roof ventilator is open in stages to meet the cooling needs. When greater cooling is required, north ventilator is open in addition to south ventilator. In summer cooling phase, the south ventilator is open first, then north ventilator is open. Okay, so this is about the seasonal use of such a ventilators. Okay, as the incoming air moved across the greenhouse, it is warmed by the sunlight and by mixing with warmer greenhouse air. Okay, with increase in the temperature, incoming air becomes lighter in weight due to the decrease in the density. It rises up and flows out to the roof ventilators. This sets up a chimney effect, which in turn draws in more air from the side ventilators, which creates a continuous cycle of the air. Okay, this system does not adequately cool the greenhouse. On the hot days, the interior walls and floor is frequently injected with water to help for cooling. So this is about the natural ventilator, natural ventilation. Next to that is the roll-up side passive ventilation. See, this is a greenhouse structure. This is made up of polyfilm. Okay. In the side wall, here we can see here. This is a pipe. Okay, long pipe along the length of that greenhouse structure. It is fitted to which a hand crank is fitted. Okay, and on which such a polyfilm of the side wall or this side wall, it is rolled on that pipe. Okay, see, with the help of this hand crank, when sunrise is there, a person giving the service at the greenhouse, he lifts this curtain by means of hand cranking, either from one side or from the both the sides. Okay, to achieve the movement of air inside a greenhouse structure. Okay, so roll up side passive ventilation. Okay, in roll up method of ventilation, allowing the air to flow across the plants. The amount of ventilation on one side or on both the sides may be easily adjusted in response to temperature, prevailing wind, and the rain. During the periods of excessive heat, it may be necessary to roll the sides up almost to the top. Means almost to the top, such a hand cranking can be done and such a curtain can be lifted from both the sides. Okay. This passive ventilation can also be accomplished by manual raising or parting the polyethylene sheet. Here, the open vent areas must be covered with screens to prevent virus diseases. Here, the holes must be large enough to permit free flow of air inside a structure. A screens with small holes blocks the air movement and cause a buildup of dust. Here, Roll-up side passive ventilation on plastic greenhouses is only effective on the freestanding greenhouses, not on gutter-connected greenhouses. Okay, so in this way, in short, we have seen such a roll-up side passive ventilator or roll-up side passive ventilation system in the polyhouses. Okay, then next to that is the forced ventilation system. In forced or active ventilation, mechanical devices such as fans are used to expel or to exhaust the air. This type of ventilation can achieve uniform cooling. This includes summer fan and pad cooling and fog cooling systems, and the winter convection tube and horizontal air flow systems. For mechanical ventilation, low pressure, medium volume propeller blade fans, both directly connected and belt driven, are used for greenhouse ventilation. They are placed at the end of greenhouse opposite to the air intake, which is normally covered by gravity or motorized lowers. Okay, here the fan vents or the lowers, it should be motorized with their action controlled by the fan operator. Motorized lowers prevent the wind from opening the lowers when heat is being supplied to the greenhouse. Here, the wall vents are placed continuously across the end of the greenhouse to avoid the hot areas in the crop zone. Here, uh, one of the example of that forced ventilation is the fan and pad cooling system. Here, in this fan and pad cooling system, okay, this diagram shows fan and pad cooling system. Uh, every fan and pad cooling system, it consists of two main components, that is cooling pad. Okay, it is made up of either charcoal or khus, okay, or different kinds of the dried grasses or cellulose paper having the structure like honeycomb. Okay, here such a cooling pad, it is provided generally of cellulose paper having honeycomb like structure. Here, height of that cooling pad is 1 meter, or this cooling pad to fan distance of 20 meter. For every 20-meter distance, height of that cooling pad must be 1 meter minimum. Okay. At the top of such a cooling pad, overhead tank it is provided. In this diagram also you can see here, this is the cooling pad. Here the overhead tank or reservoir is provided. Okay, and at the bottom of that such a cooling pad, water reservoir is also provided for collecting the water falling from this overhead tank into the body of that cooling pad and from that cooling pad into the water reservoir. Okay, what happens during the working of that fan and pad cooling system? Here in the one wall of greenhouse, which cooling pad it is fitted, while in the opposite wall, which a high volume and high speed exhaust fan, it is fitted. So when the water is pumped and it is supplied in the overhead tank of the such cooling pads, water tends to flow from the top of the cooling pads towards the bottom of the cooling pads. So during the free fall of the water by the gravity into that cooling pad, what happens? Here the air from the outside of that cooling pad or outside of the greenhouse structure be sucked inside such a cooling pad. And from that cooling pad, it is moving towards the exhaust fan, and from that exhaust fan into the ambient air. What happens when the air moves from that moves to that cooling pad into the greenhouse? Here, while movement of the air through the such a cooling pad, what happens? Fine water particles are carried by the air along with it, and that air or that moist air, it enters into that greenhouse structure. Inside that greenhouse structure, there is a increased temperature is there. Okay, so in that high temperature region, when that fine particles of the water or that moisture it comes, what happens, they get evaporated quickly inside the greenhouse structure. So due to the quick evaporation, there is sudden fall in the temperature. Okay, this is the evaporative cooling phenomenon in the science. Okay, and there is a reduction in temperature inside this greenhouse structure is achieved. Okay, and a desired cooling effect in the greenhouse structure it is obtained, and that hot air is exhausted out, or it is exhausted by means of such a high capacity exhaust fan. Okay, so this is about the working of the fan and fan cooling system. Okay, then next to that, evaporative cooling in combination with the fans is called as a fan and pad cooling system. The fans and the pads are usually arranged on the opposite walls of the greenhouse. The common types of the cooling pads are made up of excelsior, wood fiber, aluminium fiber, glass fiber, plastic fiber, and cross-fluted cellulosic material. Or in many cases, honeycomb-like structure made up of cellulosic material or khus. Okay, these are the different, or sometimes charcoal is also used. Okay, for the construction of such a cooling pads. Along one wall of the greenhouse, water is passed through that cooling pad. Okay, that is usually placed vertically in the wall or in the one of the wall of that greenhouse. Exhaust fans are placed on the opposite wall to draw the warm air outside through that pad. The supplied water in the pad through the process of evaporation, it absorbs the heat from the greenhouse air passing through the pad and from the surrounding of the pad, which causes the cooling effect due to the evaporative cooling phenomenon. Outside air is cooled to the tune of 3 to 12 degrees centigrade, depending upon light intensity, relative humidity, and amount of shading compound which is applied. Okay, so in this way, uh, desired cooling effect is achieved or it is obtained inside the greenhouse structure. Most of the greenhouse requires 1 meter height of the cooling pad for every 20-meter hand to pad distance. Evaporative cooling systems are especially efficient in low humidity environments. There is a growing interest in building greenhouses combining both passive, that is natural, and active, that is forced systems of ventilation. Passive ventilation is utilized as the first stage of cooling, and the fan and pad evaporative cooling takes over when the passive system is not providing the required or needed cooling. Okay, at this stage, the fans for the natural ventilation are closed. Here, when both the options for cooling are designed in a greenhouse construction, here the initial cost of installation will be more, but the operational costs are minimized in the long run, since natural ventilation will most often meet the needed ventilation requirements. Okay, so in this way, we have seen in short about construction and working of fan and pad cooling system, that is forced system. And next to that is the fog cooling system. This is also one of the active or forced cooling system. Okay, fogging systems or the fogger systems is an alternative to the evaporative cooling pad. They depend on absolutely clean water free of any soluble salts in order to prevent plugging or clogging of the mist nozzles. Such cooling systems are not as common as evaporative cooling pads, but when they become more cost competitive, they will be adopted widely. Nowadays, we are observing that such a foggers are being used mostly to achieve desired cooling effect. Here, the fogging systems are the second stage of cooling when passive systems are inadequate. It operates on the same working principle as the fan and pad cooling system. A high pressure pumping apparatus or the piston pump, it generates a fog containing the water droplets with a mean size of less than 10 microns using suitable nozzles. These droplets are small to stay suspended in the air while they are evaporating and utilize the heat of greenhouse air. Here, fog is dispersed to the greenhouse, and through the greenhouse, cooling the greenhouse everywhere. As this system does not wet the foliage, there is a less scope for disease and attack of the pest. Fan and pad cooling system, it lowers the temperature of incoming air by about 80% of the difference between dry and wettable temperature. And the fog cooling system, it reduces the temperature to the tune of nearly to the 100% of that dry and wettable temperature difference. Okay, so that fog cooling system, it is one of the active cooling system, and it works more efficiently than any other system. Now, this is because the complete evaporation of water is not taking place because of the bigger droplet size in fan and pad cooling system. Whereas in the fog cooling system, there will be a complete evaporation because of the minute size of the water droplets. Thus, the lesser the dryness of the air, greater evaporative cooling is possible. Okay, so in this way, just in short, we have seen about uh, such a fog cooling system. That fog cooling system, it works on the same principle of evaporative cooling effect. Okay, a very fine particles of the fog gets evaporated very quickly inside the warm or inside the hot air inside a greenhouse structure. So there is sudden fall in the temperature inside a greenhouse structure. As the fog cooling system, it generates a very fine particles getting suspended in the air. So very effectively or very efficiently, its evaporation gets inside a greenhouse structure than the water droplets which are generated in the fan and pad cooling system. So fog cooling system, it is most efficient or it is most effective. Then let us see next, that is heating systems which are used inside a greenhouse structure. Just we have seen in short about cooling systems. Let us see about the heating systems of a greenhouse structure. Here the heating system must provide into the greenhouse at the same rate at which it is lost by the conduction, infiltration and radiation. There are three different popular types of the heating systems for the greenhouses. First one is the unit heater, then central heating system, radiation heating system. Okay, unit heater, central heating system, and radiation heating system. Among them, first one is the unit heating system or unit heaters. The most common and the least expensive is the unit heater system. In this system, the warm air is blown from the unit heaters that have self-contained fireboxes. These heaters consist of three functional parts. Fuel is combusted in a firebox to provide the heat. It is initially contained in the exhaust, which rises through the inside of a set of a thin-walled metal tubes on its way to the exhaust stack. Okay. The warm exhaust transfers heat to the cooler metal walls of the tubes. Much of the heat is removed from the exhaust by the time it reaches the stack to which it leaves the greenhouse. A fan in the back of the unit heater, it draws in the greenhouse air, passing it over the exterior side of the tubes or hot tubes, and then out from the heater to the greenhouse environment again. Here, the cool air passing over the hot metal tubes is warm and the air is circulated. So, in this way, effective heating it is achieved in case of the greenhouse structures by means of unit heaters. Let us see about the central heating system. Here it consists of central boiler that produces steam or hot water plus a radiating mechanism in the greenhouse to dissipate the heat. A central heating system can be more efficient than unit heaters, especially in the large greenhouse ranges. In this system, two or more large boilers are at single location. Heat is transported as a hot water or a steam to the pipe mains to growing area. And many arrangements of heating the pipes in the greenhouse is possible. The heat is exchanged from the hot water in a pipe coil located across the greenhouse or an in-bed pipe coil located in the plant zone. Some greenhouses have a third pipe coil embedded in a concrete floor. A set of such unit heaters can be used in place of the overhead pipe coil, obtaining the heat from the hot water or the steam from the central boiler. So, in this way, a central heating system it is also provided for heating of the greenhouse structure. Okay, during the low temperature time or low temperature season, or mostly in case of snowfall or in the winter season. Next one is the radiation heating system. In this system, a gas is burned within the pipes suspended overhead in the greenhouse. The warm pipes supply the heat to the plants. Here, low intensity infrared radiation or radiant heaters can save about 30% or more of the fuel compared to conventional heaters. Several of such heaters are installed in the tandem in the greenhouse. Here, lower air temperatures are possible since only plants and root substrate are heated directly by this mode of heating, that is, by means of radiation heating. Okay, so in short, we have seen about this radiation heating system. Here, gas is burned within the pipes which are suspended overhead in the greenhouse, and the warm pipes supply heat to the plants. At low intensity infrared radiations or radiant heaters, they save 30% or more of the fuel as compared to the conventional heaters. By means of radiation, heat is transferred to the greenhouse interior. Okay, so in short, we have seen about radiation heating system. Let us see next is the solar heating system. Okay, here solar heating is often used as a partial or total alternative to the fossil fuel heating systems. Few solar heating systems exist in the greenhouses today. The general components of solar heating systems are collector, then heat storage facility, and exchanger to transfer the solar or the solar radiations derived heat to the greenhouse air. Backup heater to take over when the solar heating is not sufficient, and set of controls. Okay, so components of solar heating system are the collector, then heat storage facility or heat storage unit, heat exchanger to transfer the heat to the greenhouse air, and the backup heater. Okay, these are the few components of such a solar heating system. Various solar heat collectors are in existence but the flat plate collector has received the greatest attention or is becoming more popular. Let us see solar heating system or diagram of the solar heating system. This is the collector or solar collector. Okay, in which such a solar radiation absorbing films are provided inside that collector plate, on which such a tubings or such a copper pipings are provided. Okay, in such a copper pipes, here water or the liquid. Okay, it is filled by means of the pump. Here, what happens by means of this pump? That water it is or that liquid it is forced through such a pipe. Okay, uh, throughout this system towards the such a solar collector. When that liquid or the cool or the ambient liquid it comes in such a solar collector, then due to the solar radiations during the daytime, uh, such a films inside the collector absorbs the heat and such a pipes are getting heated and the liquid inside such a pipes get heated. It becomes very hot. Okay, they which is that hot liquid it is transferred or it is being carried into this chamber. We can say it as a heat exchanger. Here, exchange of heat from that fluid inside the pipe it takes place to the surrounding fluid. Okay, then that surrounding fluid it becomes hot and it is carried further inside a greenhouse structure. Okay, over such a tubings, uh, fans are mounted. Okay, so such a fans they are exerting the pressure on such a pipes. So what happens that air or that hot air by means of such a fans it is forced into that enclosed space of that greenhouse structure. So in this way, heating of enclosed space of greenhouse structure it is carried out by means of such a solar heating system. Now, this solar heating system it consists of flat black plate. Okay, it may be rigid plastic, film plastic, sheet metal, or board for absorbing the solar energy. Okay, the plate is covered on the sun side by two or more transparent glasses. Okay, and or the plastic layers, and on the back side by insulation. This is the back side which is provided with insulation. Here, the enclosing layers serve to hold the collected heat within the collector. Water or air is passed through such a copper tubes placed over the black plate and absorb the entrapped heat and carry it to the storage facility. A greenhouse itself can be considered as a solar collector. Some of its collected heat is stored in the soil, plants, greenhouse frame, floor, and so on. Remaining heat is excessive for the plant growth and is vented to the outside of that structure. Here, the excess vented heat could just as well as be directed to rock bed for storage and subsequent use during the period of heating. Collection of heat by flat plate collection is most efficient when the collector is positioned perpendicular to the sun and the solar moon. Okay, based on the locations, the heat derived can provide 20 to 50% of the heat requirement. Okay, so in this way, by means of such a solar heating system, requirement of heating greenhouse structure, okay, it can be achieved uh, very effectively. Then let us see next is the water and rock storage system. Let us say Here, this diagram, it shows rock storage unit. Okay, here either water or rock pieces. Okay, they may be used for storage of heat energy. Okay, here this is the ground. Then this is the insulation of styrofoam. It is provided. This is the phenol layer, which acts as a insulator. Then this space, it is filled with rock particles or pieces of the rock, and upper surface of which is provided with porous concrete floor. Here, hot air from the solar collector, it enters to rock beds for the storage. So that hot air from the solar collector, it is stored inside such a rock bed or inert rock bed. Okay. Then during the night time, in the such a heat is required for crops. Okay, in the cold regions. And at that time, that hot air from such a rocks, uh, a rock storage to the greenhouse, it is provided for the heating purpose. Okay, so this is the rock storage unit. Let us say water and the rocks are the two most common materials for storage of heat in the greenhouse. 1 kilogram of the water can hold 4.23 kilojoule of the heat for each 1 degree centigrade rise in the temperature. Whereas rock can store about 0.83 kilojoule for each rise of 1 degree centigrade of the temperature. To store equivalent amount of the heat, a rock bed would have to be 3 times as large as the water tank. Okay, water storage system is well adapted to water collector in the greenhouse heating system, which consists of a pipe coil or a unit heater which contains a heater coil. Hot water from the collector is pumped into storage tank during the daytime. In case of water storage system, when the heat is required, warm water is pumped from the storage tank to hot water or a steam boiler or into the hot water coil within a unit heater. Although solar heated water will be cooler than the thermostat setting on the boiler, heat can be saved since the temperature of this water need is raised as high as to reach the output temperature of the water or steam from the boiler. This is a rock storage unit. Then a temperature rise of 17 degrees centigrade above the ambient condition is expected during the daytime in the solar storage units. Each kilogram of the water can supply 71.1 kilojoules of the heat, and each kilogram of rock, it supplies 14.2 kilojoules of heat as it cools by 17 degrees centigrade. Okay, so you have to remember these figures. Each kilogram of the water, it supplies 71.1 kilojoule of the heat, whereas each kilogram of the rock, it supplies 14.2 kilojoules of the heat when it cools by 17 degree centigrade. A rock storage bed can be used with an air collector and forced air heating system. In this case, heated air from the collector along with air excessively heated inside a greenhouse during the day is forced through a bed of rocks as shown in the this figure. Okay, during the daytime, hot air from the solar collector is forced towards the this rock bed for the storage, and during the night time, hot air from the rock storage it is carried to the greenhouse for heating purpose. The rocks absorb much of the heat. The rock bed may be located beneath the floor of the greenhouse or outside the greenhouse, and it should be well insulated against the heat loss. During the night, when the heat is required, in the greenhouse. Cool air from inside of the greenhouse is forced through such a rocks where it is warm and it is passed back into the greenhouse. So in this way, heat exchange from the cool air to the warm air it takes place in the rock. A clear polyethylene tube with holes along either side serves well to distribute them warm air uniformly along the length of the greenhouse. Conventional convection tubes can be used for distributing the solar heated air. Here, water or the rock storage unit occupies a large amount of the space and a considerable amount of insulation is provided if the unit is placed outside. Placing it inside the greenhouse offers an advantage is that escaping heat is beneficial during the heating periods, but it is detrimental when heating is not required. Rock beds and pose a problem in that they must remain relatively dry. Okay, here the rock beds must be kept dry for effective storage of the heat. Okay, by in the rock beds. Water evaporating from such a beds or such a rock beds will remove considerable amount of the heat. So in this way, in short, we have seen water and rock storage system. Here, 1 kg of water can hold 4.23 kilojoule of the heat for each rise of temperature by 1 degree centigrade. Whereas rocks can store about 0.83 kilojoule of the heat for each rise of temperature by 1 degree centigrade. Okay. In this way, water it can store the energy or the heat. Also, rock also it can store the energy. Each kilogram of the water it supplies 71.1 kilojoule of the heat, whereas each kilogram of the rock it can supply 14.2 kilojoule of the heat when it is cooled to the tune of 17 degrees centigrade. Okay, care should be taken that the rock beds, okay, it should not be getting wet, okay, or they should remain dry when a heat energy or when a warm air is to be stored in the rocks. They should not get wet at all. So in this topic of design criteria of greenhouse for heating and cooling purposes, we have seen in short two terms related with greenhouse, a definition of greenhouse, then definition of greenhouse range is two or more greenhouses in one location are called or are referred as greenhouse range. Then service buildings, head house is a building associated with a greenhouse which is used for storage or for different greenhouse operations. Okay, that is service building or head house. They may ask in the definition for 1 mark. Then design criteria for construction of a greenhouse. It may be asked for the 4 marks. Okay, here the floor area of service buildings required for the small firms is about 13% of the greenhouse floor area. They may ask this one for the true or false or fill in the blanks. Also, they may ask on an average, service buildings occupy 10% of the growing area. Okay, you have to remember this figure 10% of the growing area. Also, floor area of the service buildings for the small firms is about 13% of the greenhouse floor area. Okay, remember both these objectives. Then we have seen all the criteria for greenhouse construction. Totally 8 to 9 criteria we have studied. It will be asked for the 4 marks, and objectives from such criteria will be also asked for say draw false or fill in the blanks. Okay, then next to that we have seen what do we mean by ventilation. Okay, define ventilation: the process of allowing the fresh air to enter into the enclosed space by driving out the air with undesirable properties. This ventilation. Okay, then we have seen in short types of ventilation. This active and passive. Okay, next one we have seen natural ventilation, that is passive ventilation. Okay, uh, we have seen in detail about natural ventilation. Okay, ventilators on the roof and sidewall accounts each for 10% of the total roof area. Remember this for objective. And how this chimney effect takes place in case of natural ventilation. Then we have seen in short about roll-up side passive ventilation. Okay, this rolling curtain arrangement on the both the sides of that ground structure. How it works? Okay, we have to remember. Then we have studied about forced ventilation or active ventilation systems. It may be a fan and pad cooling system or fog cooling systems, or for the winter season, convection tube or horizontal airflow systems. Okay. Uh, Within that, we have studied in short working principle of this fan and pad cooling system. Okay, how it works and its construction in short, or different parts of that fan and pad cooling systems in short. Then next to that, we have studied about such a fog cooling system in short. Okay, it's a working principle of that fog cooling system. Then next to that, here we have seen one major objective. Okay, and pad cooling system, it can lower a temperature of incoming air to the tune of 80% of the difference between dry and wettable temperature. Whereas fog cooling system can reduce the temperature of the greenhouse air by nearly 100% of dry and wettable temperature difference. Okay, we have to remember this one thing also. Then we have studied different heating systems in the greenhouse. We have studied initially different cooling systems. Okay, to be active cooling or passive cooling systems. In active cooling systems, natural ventilation. Sorry, in passive cooling systems, natural ventilation we have studied, and a roll-up side curtain arrangement, that is passive cooling system. Whereas in active cooling systems, forced ventilation, this fan and pad cooling and fog cooling systems. Okay, you have to remember. Then we have studied different heating systems inside a greenhouse structure. Okay, here in the cold nights to prevent cold bite to the plants. Okay, heat needs to be supplied. So different means of supplying such heat inside a greenhouse structure in the cold regions during the night are the unit heaters, central heating systems, and radiation heaters. Okay, what is unit heater? How it works? We have studied here in short. Then what is central heating system? How it works? Then what is radiation heating system? How it works? Okay, we have studied in short. Next to that is the solar heating system, which is becoming more popular nowadays. Okay, different components of such a solar heating system. It is collector, exchanger, okay, uh, and the pumps. Then we have studied about working of that solar collection system. Okay, here by such solar collectors or a solar heating system. About 20 to 50% of the heat requirement is fulfilled by such a solar heating systems, the greenhouse. Then next to that, water and rock storage system. Okay, here 1 kg of water it holds 4.23 kilojoule of the heat for each rise of temperature by 1 degree centigrade, whereas rock can store about 0.83 kilojoule for each rise of temperature by 1 degree centigrade. Okay, water is also best source of heat storage, and also rock is also a good source of heat storage. Okay, this is the sketch which shows rock storage unit. Okay, uh, 1 kilogram of the water it supplies 71.1 kilojoule of heat, whereas each kilogram of the rock it supplies 14.2 kilojoule of the heat when it is cooled by 17 degrees centigrade. Okay, uh, then in short we have seen uh, how the heat is collected and stored in the rocks or the rock storage unit, and how the heat is delivered from such a rock storage unit inside a greenhouse structure. In short, we have studied all such systems. So, in this chapter, we have studied design criteria for or design criteria of greenhouse for cooling systems and heating systems, or for cooling and heating purposes. Within that, in short, we have seen design criteria of greenhouse, two terms related with greenhouse. Then we have studied different cooling systems. Okay, in cooling systems, passive cooling systems and active cooling systems. In passive cooling systems, we have studied, in short, natural ventilation and roll-up side curtain arrangement. Okay, whereas in active heating system, forced cooling systems. That is, we have studied fan and bed cooling system and fog system or fogger systems. In short, okay. Next to that is the heating systems, unit heaters, central heating system, and radiation heating systems are there. Okay, these are the different mechanical methods of heating. Okay, uh, in addition to that, widely used solar heating systems and water and rock storage systems. In short, we have studied to supply the heat to the enclosed space of greenhouse structure during the cold nights to prevent the cold bite to the plants. So, in this way, in short, we have studied this topic. Okay, uh, students are requested to prepare for this topic or for this chapter in such a way that is enlist different heating systems, enlist different cooling systems. Okay, for the greenhouse structure. Then write a criteria for greenhouse construction and few facts and figures which I have told in this topic. So we stop here. Uh, Before ending this presentation, uh, I will tell you that from first to seventh topic, okay, all topics from greenhouse technology, that is protected cultivation, we have completed now. Okay, so we stop here. Thank you.